Thank you for joining us today. We're going to be talking about the program that's being put on to teach about APQP in the automotive sector. Let me just go ahead and get to our agenda of what we're discussing today. We're going to learn what APQP is and why there's a need for it, especially for new graduates pursuing a career in the automotive sector. And if you're new to the automotive sector, why you would still need it. How we're going to teach the subject matter and how you're going to learn about the subject of APQP. What's going to be covered in the course, how we're going to teach the core tools and the principles of APQP, and then we'll go through an example study topic of how we're going to teach the subject matter. And then we'll end off with registration information and some question and answer time. So let's begin. Why do we need APQP? What is the need for APQP? APQP, Advanced Product Quality Planning, is a specific requirement in the automotive sector. It's something that is not only mandated by the OEMs, GM, Ford, and FCA, which is Chrysler. It is also part of our certification process for quality systems, currently IATF 16949. When we launch new product, we use APQP as the guideline for how that product is brought from design to the beginning of production. And there are core tools associated with APQP. There are risk assessment tools, there are statistical tools, there are communication tools, and very importantly, it also describes who is responsible for what portion of that launch process so that the correct people can be involved at the correct stages, because as you can imagine, launching a product or multiple products can be very challenging and demanding on the resources of a particular organization. So why the need for APQP? If you're just starting in your career and you're graduating, you may be in an interview and they may ask you, do you have experience with APQP? Or they may reference some of the core tools considered under APQP, and you may have actually taken a course. But when you're asked or challenged to actually describe an example or to give feedback on how you would handle a situation, given an example by your interviewer, we find that most people don't have an answer for that. And that's the feedback we've been receiving. So this course is designed to give you specific case study application, not just learning about the subject through textbook material, but through real life case studies and real life examples and using lessons learned from industry. If you are in your career, you'll find that, and you have been exposed to APQP, you'll find that there are many different versions floating around. There's the version that's dictated by your organization, and then there's the version that everybody else is implementing. So this course also helped tie in to the standard in the automotive sector as GM, Ford, Chrysler is requesting it. This is transferable to the non-big or traditional big three, Toyota, Nissan, as well as some of the sub-suppliers from PSA. They all follow similar formats, and they all do fall under a flavor of APQP, so these lessons are transferable to all the automotive OEMs. You may be practicing APQP now. This is a good opportunity to streamline and speed up your learning curve, to help you understand by being coached and mentored by somebody. And that somebody in this case would be myself. I'm bringing 27 years of experience launching automotive product. My experience includes late recovery. That is a program that has gone past timing deadline, and we have to get the team organized. I am an educator within the industry, so I currently work as a quality engineering manager at Martinrea, but I'm also a designated trainer within Martinrea, mentoring and teaching the subject matters that we're talking about today, APQP, as well as the core tools within APQP. We'll discuss those a little bit in a moment. So I bring 27 years experience, but I'm also an experienced mentor that can help break down the most important portions of APQP. To give you an example, we have multiple books that they'll reference, many books, all the AIG standards. You're going to read them and you're going to understand the definitions, but how do you apply those standards? I'll help you break down and take away what you don't need and what you can keep as reference material on what is the key takeaways, risk assessment and application. And that is the key for all of APQP. It's risk assessment and application for timely launch. The program is structured so that we're not reading through a manual. It's not structured as a pure lecture where you just listen. It's interactive. There will be tons of examples, real-life examples. And at the end of all this, we will also be sharing our case study or in-class homework with a panel that'll provide an opportunity for you to go and actually see for yourself how it's applied. So we can arrange for a winning group to go and after they've completed their case study, go and actually visit. Okay, so and then you must have missed this then. So these are all the books that AIG will get you to read, the core tools for different AIG subject matter. We will reference those, but we will not regurgitate the content in those particular reference manuals. Instead, we'll use case studies and apply the lessons from those reference materials. And the key here is over the 100 hours of this course, we will be practicing real-life forms, real-life formats, and real-life structure. So to give a high level of what we're talking about here, the very high level is, if you look at the left-hand side of the screen, that is the standard product quality planning timing chart that is dictated by the APQP manual or the guideline. That is what you'll learn in any subject that you take by a third party. However, that is not what the OEMs actually use or the suppliers to OEMs use. They've taken that and they've all modified that into their version of a gate and phase review process. So we will learn how to break down the theoretical product timing planning chart or product quality planning timing chart and how it's actually applied by the largest of the suppliers to the OEM industry, whether it's Martin Rea or any of its competitors. They all use a similar process. So we will review gate and phase review, the different points which deliverable becomes relevant and important, and that helps you to streamline. We'll teach you through this course what needs to be done at what stage of timing so that you're not running around trying to solve all problems at once, but only the relevant problems when they need to be solved. So we've made reference to the AIG reference manuals. That is the core for all of APQP. Those reference manuals are the backbone and the structure. But again, we won't be using those as our primary teaching tool. We'll only be using those as a reference material. Instead, we'll be going through and breaking down and using those materials to actually apply lessons learned. So that if you're asked a question or you're in the situation where you're applying APQP, this would be for a quality engineer, a manufacturing engineer, a process engineer, an industrial engineer. You'll be able to actually give specific examples of how a particular core tool is used. We'll define roles and responsibilities. That's very key. I'll repeat that over and over again because if you know who the right resource is to conduct a particular deliverable, then you will save time trying to figure it out in the real world. Planning and management tools. Management has key responsibilities for APQP. We will discuss what individual resources are responsible for, but what the management team is responsible for as well. And it's key to make that divide because ultimately the management team is responsible for the success of any launch activity. We will develop process flow from scratch. We will use real-life examples and develop a risk-assessed process flow and cell design. We will drive that into an actual risk assessment tool. We will apply core tools for designing our quality control system, which is the final output of APQP. We will learn to understand that data. We will learn to look for bias in that data. We'll learn to apply statistical tools to make sure that the information we've come up with is feasible and realistic, and we can use it to validate our process and our product design. We'll also, and this is key, we will spend quite a bit of time looking at customer-specific requirements. What is GM, Ford, and Chrysler specifically looking for? And this is something that's not negotiable. Your OEM customer wants to see these things. So if you have exposure to an experience, the actual customer-specific requirements to those requirements, that'll give you an advantage not only in the interview process, but also in your early career. You won't have to chase things down. You'll have exposure. Over 100 hours, we will go through multiple customer-specific deliverables and actually fill out those deliverables. We won't just talk about them, we'll actually do them. And then, of course, we'll be using advanced techniques, not just simple basic introductory items, but we're using advanced techniques. And on that point, I'd like to introduce you a study topic, an example study topic. This is one of the advanced techniques that we'll be going through. So the product on the screen is a real-life product. This is a primer pump used for the start-stop feature on multiple products built by both General Motors and Ford. This was a joint program. When your vehicle stops at a stoplight, this pump initiates fluid into your transmission to keep it lubricated so that when your engine starts again, when you leave at a red light, your transmission is well lubricated and it's a smooth transition. So this function is shared by both Ford and Chrysler on a common transmission on a high volume product, and this was built by one of the suppliers. This had to follow a APQP structure. No negotiation. They were required to, and work with both Ford's customer-specific requirements and General Motors' customer-specific requirements. So this is one of the example topics we'll go through. And what we're going to learn here is in this example topic, we were given 3 subcomponents. As you can see, there's a top cap there. There's the actual motor itself, and then the bottom portion of the motor. They had to be merged into a single assembly, assembled individually, assembled into a single assembly, and each product had to be completed within 10-second takt time. We were given 4 weeks of preparation before the cell could be quoted, so we had to come up with a process design in less than 4 weeks, and we had a mandate, of course, you always will, to minimize our footprint and labor requirement, and almost always make it for the least amount of capital money. And any supplier you work with will be utilizing lean concepts. So we throw in all the lean concepts at the process design stage. If you are designing a process, it's best to apply your lean lessons at the beginning and not after your capital money has been spent. It's more expensive to correct equipment than it is to design it correctly in the first place. So part of the 100-hour course is doing that from scratch on a simple example than a more complicated example. So we will be going through actual case studies. And then for your project, you will do that yourself on your own case study. We go through the lean principles. We understand, you may have heard plan, do, check, act, but we understand how that relates to the continuous improvement function, what that means to IATF 16949 certification, which is the standard for quality certification within the organizations that supply the OEMs, and how to actually apply that, not as just a philosophy, but as a real-life tool to use every day in your job. Not only is it a philosophy, it is a requirement. You will be challenged in your job in the automotive sector continually to find improvement for many different things, and we'll talk about that in a moment here. We understand from our basic lean lessons that the 9 waste or 8 waste, depending on how you break it down, are what we're trying to eliminate. But there's tools for achieving that, and those aren't always discussed. Those advanced tools, we'll be going into discussion on those. But just a quick reminder for those of you who've taken your lean class, we're always trying to eliminate transport, inventory, motion, waiting, overproduction, overprocessing, defects, and the most importantly, wasted human talent or human potential. If you take a generic third-party course on APQP, they will not get into specific examples for the automotive industry. They'll keep it fairly general so that they can teach it to a broad scope of individuals. And this is so that they can keep seminars to 1 or 2, maybe 3 days. In this course, we actually break it down and use examples from all the key process elements that suppliers have, whether it's joining, which includes welding and adhesive application, machining, which is material removal, forming, casting, molding, which also includes powdered metal technology and additive technology. We will use examples from all the major processing types and not keep it generic. We will get into very specific examples. So if you already have exposure to an industry or you are considering an industry, the examples we will use will help to shape your understanding of APQP for those industries or shape your expectations of what you will see in the automotive sector if you have not been exposed yet at a true and accurate level as opposed to a generic level. One of the tools that we'll discuss are Torille diagrams, and we'll use those exclusively for determining inputs and outputs. It's a basic tool, it's a standard tool, it's outlined by the AIAG format, it's a requirement in IATF 16949. So we use this tool. Eventually, you'll be able to develop inputs and outputs automatically, but this tool helps us to develop that thought process. And here's a quick example. If we look at the process of gauge calibration, and we look at what equipment's required, what methods required, what triggers the process calibration, what are the people, the resources required to do that process, and how do we determine the effectiveness or validity of that program through our measurement, then we have an output that we can actually rely on. And if we have an issue and we need to look for sources of variation to eliminate problems, we can now break it down. This is no different from Ishikawa. This is no different from our lean classes, but this is applying real life examples over and over again until this thought process becomes automatic and we become proficient at problem solving using basics. So how do we apply this to our problem of our assembly having to be merged? Well, here's an example study topic that we talked about, the cardboard city. This is an advanced topic. Not everybody uses this, but the top suppliers, the top by income, gross income, and by profitability, they are all using this methodology for assembly. We originally got the cross-functional team together on the example of this motor, this pump for the 10-speed transmission of both Ford and GM use. And originally what we came up with was just over 1,000 square feet utilizing 8 operators. And this is how we believe we can get that 10-second takt time. However, by looking at the design, most of you who've taken a lean class will say that's not a lean cell, and that is true. We identified concepts that were not lean. For instance, in lean, we don't want islands, we don't want to walk around things, and we want to minimize how many branches or legs are in our cell so that we can tack up and down as volume requirements change. If the volume goes up, I should be able to add additional bodies, and they shouldn't be bumping into each other. If the volume goes down, or we're in ramp-up phase where the volume is lower, I should be able to reduce the labor count, and they should be able to slide from cell to cell quite easily without having to walk around big islands within the cell. So we got the cross-functional team together, our lean experts, our quality experts, our production experts, our operators, and we came up with a second iteration. We dropped it down from just over 1,000 square feet to just under 800 square feet, still with 8 operators, but now we've incorporated all the lean tools and exercises and tricks. So in the 100-hour course, we'll be reviewing those tricks and going into great details. How do we go from 10,000, just over 1,000 square feet to just under 800 square feet? And what tools and assessment tools we used here. And the one key tool here is charades. We actually had operators mock assemble product within this cell. This is just cardboard and totes, nothing expensive. This is a little bit of time to put it together, but we put it together with a cross-functional team. It took us a day to set this up and a day to review it. Once we did this and we got our charades done, our mock assembly times, we were able to develop combination tables, which you may have learned about, and if you didn't, we will be learning how to put together combination tables. And that gave us an opportunity to come up with our first CAD version of this design, which dropped our footprint even more to 570 square feet. But when we did the charades, we also identified that we could do the 10-second takt time with only 5 operators. By applying those combination tables, we had a very clear understanding before a single dollar was spent and a single integrator was engaged on what we wanted and what was feasible. We will own the process. As a supplier, you own the process, not the people building your equipment, you. And how do you get ahead of the challenges and hurdles? By understanding your process. So by providing this to our integrators, we came back with a proper layout developed by the experts, our integrators, and we further reduced the footprint to 250 square feet, still with 5 operators at full volume. So all in all, we started, and in less than 4 weeks, we went from 1,050 square feet and 8 operators down to 250 square feet with 5 operators. At that point, we quoted the product, the process to make the product, and we were, within 4 weeks, very clear on what our process was going to be and where our money was going to be spent and how much money was going to be spent against a budget. And it's very difficult to defend your position on the equipment you want when you don't have this legwork. You'll find that in industry, there's always a push for less money to be spent and less people to be used. If you use these methods and tools to develop your process, you already have your evidence in front of you to prevent challenges and to speed up the process of launching your process design. So this is an example study topic for the course. If you can imagine what we just discussed here in a few minutes, the course itself is 100 hours of this kind of material, specific examples, utilizing our reference material, real life examples, real forms and processes, and the interactive ability to answer questions as we develop. It will be broken down into weekly segments with takeaway homework, and we will have it broken down into six sessions in this year and then 6 sessions in the new year. I'm going to pass the microphone over to our friends at the other end of the microphone to help discuss registration information, and then we can get into some question and answer after that.
Thank you. Yes, so class will be held on Saturdays from 9 until 5, starting on October 19th. There will be a break in December, so the last class will be November 23rd, and classes will start back up January 4th, and again every Saturday until February 8th. There will be a product launch competition where you will be put in a small team, and we'll have industry experts come and provide you with feedback regarding your product launch presentation. So there will be a panel of judges, and the classes will be held at Windsor Hall downtown campus. The cost is $9.95 plus HST, and that's for both sessions from the fall and the winter. And it'll include all of the materials. And you can register at continue.uwindsor.ca. We do have a new registration system, and you can pay through credit card. You can use your existing login, UWin ID and password on the left side of the screen. And we have a lot of interest, so please register soon, as we do expect spots to fill very quickly.